All right, so the next section we're going to be talking about is going to be dealing with what's called parallel lines. And you've probably heard of parallel lines before, but parallel just means that you have two lines that are separated in such a way that they will never touch. So there's a space between them that's always going to be the same, no matter what part of the line you're on. So this line, if it keeps going forever and ever, this line keeps going forever and ever, and they will actually never touch each other. So the symbol that we use for this is we'll say that line A is parallel to line B. All right, and so sometimes shorthand you'll see it written like this: A is parallel to B, and that just means that they will never intersect and they will never touch each other. Okay, so a big thing in geometry deals with parallel lines that are actually cut by a third line. So let me draw two parallel lines right here. All right, and these are going to be cut by a third line. So we're going to draw a line right through the center of these. So something like this. Okay. And so this is what's called a transversal. All right, so the transversal cuts these parallel lines into different angles, different sections. So this is a transversal. All right, a transversal line. Okay, and so what we have here is we have an angle here. All right, which has to be the same as this angle over here because of vertical angles. And then also looking at this, there's really not a mathematical proof for this besides the fact that since these lines are parallel, the slope of this line is the same as this slope. All right, that this angle up top has got to be the same as this angle here, and it's just one of those things that's mathematically intuitive. All right, so since that angle is equal, then these are vertical, so that has to be equal as well. All right, and so then let's look at the other side. So this angle is going to be equal to this angle. And then for the same reason as we said before, because this line has the same slope because it's parallel, this angle is equal to that angle up top. And these are vertical, so that angle is equal as well. So we have a parallel lines cut by a transversal. We see some of these angle relationships here. For example, if this was 50 degrees, all right, then we know that all these blue angles here are 50 degrees. Okay, and so since that is 50 degrees, you know that along this straight line, all right, that has to add up to equal 180 degrees all the way around. So 50 taken out of 180 degrees, that would mean that this orange angle is 130 degrees. And so all the way around, this is going to be 130 degrees. Okay? And so there are several different types of angle relationships that you can have within parallel lines. All right, and so what we're going to do is we're going to talk about some of these relationships. All right, so the very first type that we're going to talk about is going to be corresponding angles. So corresponding. And that's the very first type that we talked about. Corresponding angles are angles that are in this type of relationship. Okay, or it could be, again, it could be over here like this. They could be in any type of spot, there and there. And then lastly, maybe a star is corresponding to the star. So these angles are in the same spot in regards to on the same side of the transversal, and they're on maybe the top or the bottom of the parallel line. It's kind of like it's in the same spot. You just slid this parallel line. If we slid it all the way down, it would match. Okay, and so the thing that we know about corresponding angles, I know that the measure of the angle at this dot is going to be equal to the measure of the other angle, all right, in these two spots right here. Okay, so all the corresponding angles are going to be equal to their corresponding angles. So the dots are equal, the squares have the same angle measure, the star is equal to the other star, and the triangle angle is equal to the other triangle angle. Okay, so corresponding angles, that's your very first type that you have. So, for example, if this was maybe 2x degrees, and your other spot, your other dot was maybe, I don't know, x plus 40. Okay, what we could do is we could say, well, we know that those are equal to each other, so we could say 2x is equal to x plus 40. All right, and then we could solve this by subtracting x, and you get that x is equal to 40 degrees. Okay. All right, so that's our first type. The second type, I'm going to draw these parallel lines a little bit differently here, just so we can see some different examples. We're going to look at what's called alternate interior. All right, alternate interior angles. Okay, and alternate interiors are going to be on alternating sides or different sides of your transversal, and they're also going to be on the interior of your parallel line. So there's my interior of my parallel lines. So what we mean by that, we have alternate interiors. That angle is going to be alternate interior with this angle. And what we know from our very first thing that we talked about is that these alternate interiors are going to be equal to one another. So their angle measures are going to be the exact same. All right, so that's not the only set of alternate interiors. Obviously, you have this set over here. Maybe this is the square. These are also equal to one another. So we could have our square is equal to the square. So we have alternate interior angles. There are also things called alternate exterior. So I'm just going to abbreviate here, alternate exterior angles. And if alternate interiors are on alternate sides of the transversal and on the inside of the parallel lines, then it makes sense for alternate exterior to be on the outside of these parallel lines. All right, so alternate exteriors would be like this. So maybe the triangle on the other side of the transversal is going to be down here. So that is an alternate exterior angle. And again, we know that those two angles are going to be equal to each other. There's one more set of alternate exteriors. I'm going to do this in green. This set is up here. We're going to make that the star. Alternate exteriors are also equal. So the star is equal to the star. Okay? All right. One more type that we're going to discuss. Okay, and this type is going to be what's called same side interior angles. Same side interior. Okay, sometimes same side is also called consecutive. All right, so you could see this as either same side or consecutive angles. All right, and so again, same side interior, they're on the same side of the transversal, and they're on the interior of your parallel lines. So you're going to have, say, this angle and this angle. So they're on the same side of that transversal, but they are going to be both on the interior of your parallel lines. And so let's go back to our original picture. And these same side interiors would represent those two angles. They're on the same side and on the interior. And you can see from our very first example that these are not going to be equal to each other. All right? But in fact, that there is a really special thing about these two, about 130 and 50. Well, some of you may have already noticed it, but 130 plus 150 is going to be equal to 180 degrees. All right, and so these same side interior, these consecutive angles, are going to have a special relationship that they are supplementary. All right, so if I have this dot here, let's say that this is a square for the same side interiors. They are not equal to one another, but they do add together to give you 180 degrees. So we have that these two are going to add to give you 180 degrees because they are supplementary to each other, just from our first example. Okay, so you have your four different types, corresponding alternate interior angles, alternate exterior angles, and you have same side interior angles. The first three, corresponding alternate interior, alternate exterior, they are equal to one another. They have the same angle measures, same side interior, or same side exterior actually as well, are going to add to equal 180 degrees.